So I wanted to go ahead and give a quick update. I've only been back from my trip since yesterday, and I haven't had a lot of time to work on this, but I've actually been able to get some really good progress completed, and I wanted to go ahead and share that with you. So if you recall, the last time the last update, we talked about needing sort of two things. We needed to be able to run NetLogo on the JVM and use NetLogo as our fitness function. It's going to generate fitness values that we're going to use to intelligently search for simulations. And then in Python, we need to be able to get those, we need to be able to call that fitness function and get its return value. So I've actually been able to get this to work, and it's actually really cool. So let me go ahead and show you what we're going to do. So I created this class in Java, this indism3 controller. It defines a fitness function. This function takes all the parameters that the NetLogo takes, the indism3 NetLogo model takes. You can pass in all these parameters. It will create an instance of the simulation on the JVM, of the NetLogo application on the JVM. It will set all the parameters, it'll run it, and then we can actually return values from the simulation that originally we were, if you recall, a long time ago, we were actually printing these values to a file. We can return these values and actually print them to, we can print them to the standard out of the terminal, or we can actually return them to Python and print them out in Python. But let's go through this real quick. So we can actually just go ahead and run this code in Java, and what will happen is we're just running the main function in Java, and we're going to call the fitness function, pass it these parameters, and you see we printed out the return value. So this is your total population. This is the population of pink turtles, and I think that is your producer, and then the population of the consumer, which is 0. Now, I'm not sure how accurate these values are. I think there's still some work that needs to be done on this code to make sure that we're generating the right values. But regardless, we are able to call NetLogo on the JVM, run it with whatever parameters we pass it, and then get these return values, because these return values are later on what we're going to be using to calculate the fitness of each simulation that we run, which is how we're going to calculate basically that's going to be pivotal to the genetic algorithm, which we'll get into as we progress in this. So let me go ahead and run this. So we're going to call this, and it's going to be sitting on the JVM waiting for us to call it in Python. So we're going to call Python, and it's going to do its thing. It's going to basically get this code from the JVM. It's going to get like an address, a pointer to it. Then we're going to get an object of this, and we're going to call from that object. We're going to call this same fitness function, and we're going to pass it these parameters, and we're going to get a return value, store it here in the fit variable, then we're going to print that out. And sure enough, that's exactly what we did. And we can run it again and just watch it. So we're getting back the same value here. So we are making really good progress on this, because now once I get everything working, proof of concept, basically. We know now that we can do this. Now it's more about making sure that, the code is, the NetLogo simulation is outputting the correct values, making sure that we can automate the execution of the Java code on the JVM from Python, which is really what this code is right here. And then once we do that, really we can just start to focus on the pure genetic algorithm implementation in Python. And hopefully in my next update, we will have that ready.